you can see from the agenda, you'll see that on conference day 2, track 1, it's supposed to be pushing the camel through the eye of a needle, presented by Mr. Haroon Meer, Technical Director of SensePost. This has now been revised, and it's our honor to have Mr. Charl van der Walt to actually present. Mr. Charl van der Walt is the founder and managing director of SensePost. Without further ado, I'll hand this over to him.
Thank you very much. Good morning, everyone. So again, my name is Charl van der Walt. This talk is titled Pushing a Camel Through the Eye of the Needle. And it's really a discussion on new and emerging techniques for tunneling data in and out of protected networks. Just a brief note about myself and about the company. My name is Charl. As was pointed out, I'm standing in for Haroon, who's our technical director, who unfortunately couldn't be here. My role at SensePost is managing director. I think it says on the website that I was a founder of the company, or the founder of the company. That's not strictly speaking true. I was one of the founders, along with a couple of other guys, including Haroon, who couldn't be here. SensePost is really a penetration testing company, so we spend most of our time trying to compromise networks on behalf of clients. And when we're not doing that, we're thinking about new ways that we can do that. We're based in South Africa, and we're a smallish team, about 20 people. Our client base is spread all over the world, about half of it in South Africa itself, and about half of it in other countries. I just wanted to make a couple of notes about this talk before we go into it. Firstly, I would classify this as an intermediate talk, technically. So don't expect to find deep technical insights here, but also I hope not to bore you by making too many assumptions about things that you don't know. So there's certain concepts and fundamentals that I will assume that you know, and I'm just going to gloss over them. This talk is about exploitation, not about vulnerabilities. So really what we're focusing on here is how you can leverage off an exploited machine to gain access to the rest of the infrastructure, the network that machine sits on. So we're not going to be focusing on things like, although I'll be speaking about it extensively, we're not going to be focusing on things like SQL injection. We're going to be focusing on how you leverage off SQL injection basically to be able to create a clear channel in and out of the compromised environment. It's a long talk. We've got about 70 slides that we have to cover, and for that reason I'm going to have to go pretty quickly. And along with those 70 slides, I've also got quite a large number of demos, those so-called live demos that we all like to do. So we're really going to have to hustle through it pretty fast. And because I'm doing so many demos, of course, a lot can go wrong. And if it does, I'll have to ask you just to have a bit of grace for me. I think you all know what it's like. And then finally, I just need to point out that the work that we're going to be presenting, some of it is a recap of old work that other people did. Some of it is new research that our team did. But it's not exclusively my work. It's a whole team of guys who worked on this. And really the guys who should have been here are Haroon Meer and Marcos Lavera, who did the heavy loading really on this. So what is this talk about? Let's have a quick look at the agenda. I'm going to be using these agenda slides to help you keep track of where we're going because of all the large amount of content that we have to cover. So I've spoken a little bit about context. I want to spend a little bit of time about why we care. So why do we spend time looking at the subject of tunneling data in and out of networks? I'm going to give you a brief history of our thinking over almost the last 10 years. So how we arrived at the point where we are now in our thinking. I'll give you a quick demo of something we call a CGI Shell 2.0. It's really just an excuse to introduce Web 2.0 into this talk. Because these days, if you want to have a successful talk, you have to talk about Web 2.0. So we thought we'd throw a little bit in there. We'll go back and do some more history. I'll recap that. I'll summarize that section a little bit. And then I'll introduce the first new technology, which is something called Reader. Reader is a TCP over HTTP tunneling tool that's been written in JSP, so it's easily uploadable to a compromised server. We're going to go back then, after Reader, we're going to go back and revisit something our team did last year, which is a SQL injection tool called Squeezer. And we're revisiting it for a very specific reason, because we're going to come back to it right at the end, and you'll see how all of these things start coming together. After Squeezer, we're going to look at something new in the form of OLE object instantiation under SQL. And basically what we're going to show there is how we can create executable objects on Microsoft SQL 2005, and then run those objects or execute those objects using SQL. And we'll bring all of that together then in a new technology that we're calling Server, which is a TCP over SQL over HTTP tunneling tool. So you'll see all of these pieces will come together right at the end, and hopefully we'll have some time for questions. Right, so why do we care? Essentially, I'm going to make 4 points. I'm going to say we're still often in the position that we can compromise servers. Most often, those will be web servers and SQL servers. But because of best practice around network security and security topology, we very seldom have a way to tunnel data in and out from these compromised servers. And because of these tightened networks, we have to look at what's left for us, which is essentially HTTP. So what I want to do is I want to quickly look at the PCI standard, PCI DSS. Everyone must be hearing about it. It represents best practice, entry-level best practice for network security. And you'll see why these best practices are making our life difficult. First thing it says is, you need to patch your boxes. So the chances that we're going to find a trivially vulnerable server exposed to the internet today have become much smaller than they used to be. This is all talking on the internet, of course. So that box is patched. The next thing they say is you need to put your box behind a firewall. It's pretty obvious. We've been doing it since about 2000. And we need to block everything except allowed ports. And on the internet today, allowed ports are ATN 443 primarily. So that gets shut down over there. Next, they say use SSL. We don't really mind about SSL. It makes no difference to us. Whether the web server is exposed over HTTP or over HTTPS, our attacks are going to be the same. Then they say you need to split your stuff up, right? The component that's exposed to the internet, namely the web server, and the component that carries the sensitive data, namely the database server, need to be put onto different platforms. And so we create this concept of a DMZ, and we segment the database away from the firewall. And you end up with a situation like that. And then finally, the standard says you need to block all inbound and outbound traffic. So not only is your SQL server tucked away there, but you're also not allowed to tunnel data in or out. And this is what in penetration testing we would call a hostile environment. So even if I can launch an exploit, say via SQL injection against the SQL server, the exploit runs there in isolation. I've got no way of getting anything back from it, right? No way of getting the output from my commands because of where this thing is locked away. And it's this scenario, which is increasingly common, that leads us to think about these new techniques for tunneling data in and out. And of course, like I said, we're forced to use what's left to us, which is essentially going to be the inbound HTTP channel. And of course, the SQL connection between the application server in the DMZ and the database server, wherever that's located. Right, so I want to take a few minutes and just recap how our thinking has progressed over the years. I'm going to start by looking at what we did before the firewall. We'll look at the CGI shell, and then briefly at how we got binaries onto servers. So before there was a firewall, everything was easy. We could access victim servers on numerous different ports. And once we'd compromised those servers, we could access various other servers. And so the challenge was really just to find the compromise. Once you had the compromise, you had full control over that server without any restrictions. Those were the good old days. But of course, then firewalls were introduced. Firewalls would filter typically incoming traffic and only allow connections on port 80. So even once you had a compromise, it was difficult to, for example, spawn a shell listener because there were no other ports that you could connect to. And so people started using this idea of web-based shells written in ASP or PHP, whatever the case is. And the idea is that you construct this script on the web server, put it in an executable directory on the web server, and then launch it using your browser. And then using this HTTP channel, you could easily execute commands and see the returned output. And outbound traffic was still allowed typically, so it's easy to get other stuff out, right? If you wanted to create a tunnel, that would be relatively easy because the firewall would allow outbound TCP connections. To get binaries onto the server, typically we would use an extension of the same technique. What we would do is build an upload script, again in ASP or PHP or whatever the scripting language of choice was, and then using that script, we would upload the binary that we wanted onto the web server and then execute that binary, typically by hitting it with the browser again. And so a very common technique, it was even implemented seamlessly in some worms, was to build the upload script, upload something like netcat, and then use a netcat reverse shell to connect to the box, and then you've got interactive control over that machine. Right, now my first demo. You'll see I've included this picture of a handsome man. I got this tip from Dino Daizovi. He said that you should have pretty pictures in your presentation. So I've included pretty pictures of bodybuilders. And I'm going to give you something to look forward to, because right at the end, I'm going to have a picture of myself, also like this. So it'll keep you interested and ensure that you stay. Right, so the first thing I wanted to show you is my Web 2.0 demo. This is something we call exec.jsp. This is typically, if I have the ability to execute commands on a server, what I will do is I'll execute a series of commands and build this JSP script in an executable directory of the server. And it basically gives me interactive command line functionality, if you can type properly. All right, so there you go. I can now execute commands on the compromised machine using basically HTTP or over HTTPS. It doesn't make any difference. The only thing that makes this shell any different to previous ones that we used to see is that this uses that AJAX-style HTTP request object, which allows me to make all the HTTP requests in the background, and so you get the sense of having an interactive shell as opposed to the old days where you would post and receive and post and receive and post and receive. All right, so that's just an example of how it used to be done in the past. So we move on through history. The next thing we wanted to get right is something called pivoting. So assuming that we were able to execute commands on a machine and assuming we were able to get binaries onto that machine, what we would want to do is proxy off of that compromised machine to make a further TCP connection into the private network, right, into the victim network. So typically how we would do that is we would create the pivot on the victim, that's this box here in the middle. Start whatever your pivoting software was. We had a package called TCPR, Foundstone had fpipe, and I'm sure there were a number of others. You could even do this by stringing a whole lot of netcat instances together in a very complex fashion. And then basically you would create a listener on the pivot. You would then make a TCP connection to that listener, and the pivot would then make an on-bound TCP connection to whatever the target server was. And you would end up with this kind of proxied TCP connection via the compromised host to whatever the victim was on the inside of the network that you wanted to compromise. Package tools like Metasploit and Core Impact do this now automatically for you. All right, you could also do it using other tools like, many people didn't know this, but XP, if you loaded the IP version 6 stack, would allow you to fire up something called a port proxy, which you could do using NetSH, and that port proxy would in fact give you exactly the same effect without having to load any third-party binaries onto the system, which was convenient. Of course, if you were on a Linux machine, you could also use SSH tunnel. And this is also a very old technique. It works in exactly the same way, except that it requires that the victim machine runs an SSHD. So if you've compromised a Linux machine that's exposed to the internet, use SSHD in listen mode. You connect to it from a client. Server makes an on-bound connection. The client creates a listener. And so what would happen is you connect to the client makes an SSH connection to the daemon forwards that connection onto the victim host. And so we're tunneling via this compromised server into the private network. Of course, this is still assumes that I can find a port that's exposed to the internet on which I can bind these listeners, right? All of these scenarios assume that. And of course, that's the fundamental restriction. That's the premise that we started out with, is that that's not possible. So a more interesting idea, which is implemented in SSH, but was also implemented in a number of the pivot tools, is to make an outbound connection. So what I would do is I would, in this case, run the client on the pivot box. I would make an outbound connection, so out through the firewall, to a SSH daemon, which is running on a machine that I control. And that creates a listener in turn and tunnels that connection through. So what I've got now is I've got an inbound TCP stream, but via an outbound TCP connection, which is which is much more useful, assuming the firewall is blocking incoming connections, but allowing outbound connections. And with Windows tools like PuTTY and plink, you could potentially upload Windows binaries onto the servers and use them to get the same effect, even if the victim wasn't an SSH box, a Linux box at least. All right, and then I wanted to take a moment just to introduce something else, which is really a useful tool in these kinds of scenarios, which is something called DNS to TCP, which is basically a TCP over DNS tunneling tool. And where we started using it was on open Wi-Fi networks. You know these Wi-Fi networks that have got captive portals? So you can connect to the Wi-Fi network, and then the minute you hit a website, it redirects you to the captive portal, and you have to authenticate or pay up or give your credit card, whatever the case is. Now, in these cases, the captive portal often allows outbound DNS queries because they want you to be able to resolve the first website that you go to before they redirect you to the captive portal. And so outbound DNS is allowed. And so this tool, DNS to TCP, is really useful. What we do is we effectively create an IPsec tunnel endpoint that listens on a Linux box somewhere on the internet. Then we use DNS to TCP to tunnel to this IPsec tunnel endpoint. And via DNS queries, we can then tunnel TCP traffic out of the Wi-Fi access point, and you basically get free internet access without needing to pay. So that's where the tool came from. And it's really handy to have it in your arsenal if you travel a lot like I do. But you can use it like this also. In this scenario, you'll see outbound TCP connections are blocked from this network. This is the network we're trying to compromise here. Outbound TCP connections are blocked on the firewall over there. But outbound DNS queries are allowed. So what we do is we upload the DNS to TCP software onto this compromised server. We use that to create a TCP over DNS tunnel. So all the outbound traffic is now DNS. And then I fire up my reverse SSH, which then gets tunneled over DNS. It creates that listener on this box over here. I can then connect to that listener, and that connection in turn then gets tunneled over the SSH. And I've now got inbound TCP over outbound DNS, all right, which is nice, provided that all of these core elements are there. So provided that we are allowed outbound DNS, and provided that we can upload these tools onto the victim box, this is a nice way to get traffic in and out of a network relatively seamlessly. All right, it's a bit cumbersome, but it works well. So that's in terms of a history. Let's just summarize that. In the old days, when we started compromising machines, we were basically able to do everything we wanted. We could hit anything we wanted. Firewall didn't really play a role. And particularly even when firewalls started blocking inbound access, they were still for a very long time allowing outbound access. At least DNS was allowed outbound, but very often even TCP was allowed outbound. And as long as you've got outbound traffic and you can execute commands on a machine, you pretty much have game over. Life was easy. But given that outbound traffic is getting blocked now more and more, that becomes much more difficult, and we have to start looking more closely at using the channels that are allowed, and that's primarily going to be HTTP or HTTPS. Right. So in terms of the agenda then, we've had a quick look at the history. What I want to do now is introduce this idea of TCP tunneling over HTTP. And this isn't something new either. It's something you would have seen in various shapes and forms. What makes this nice is that we're talking about a single file scripted implementation. And effectively what that means is that if you can find a machine that's exposed to the internet and HTTP and execute commands on it, then you can build this file on that machine. And you can do it really through a series of echo commands, redirecting line for line, reconstruct the file on the web root of the compromised machine. And then we hit it basically via an HTTP request, and that starts this component on the server, and we're going to use this component to tunnel TCP over HTTP. The one I'm going to show you is written in Java, but we also have implementations that are written in ASP and PHP. So you've got one tool for every possible environment. Right, so just the assumptions. We're assuming we can hit our target on port 80 or 443, and that via some sort of exploit, we've got the ability to upload or create a web page. Now, bear in mind, that doesn't have to be because of a missing patch. It doesn't have to be an overflow or anything complex like that. It could be just exploiting some existing functionality, like a poorly configured JMX console or something along those lines. We're assuming that the network level filtering is tight, otherwise we wouldn't have to do any of this. And we're assuming there might be reverse proxies in between. So the machine that you're hitting may not actually be the machine that you're compromising. So we gave this problem to one of our interns, a young man by the name of Glenn. That's what he looks like. I'm just kidding. This guy's an Aries, by the way, apparently. Aries. It says so on his MySpace page. They're very nice people, Aries. All right. So let's have a look at Reader. The first thing I'm going to do is just verify that it's running. Okay, so reader.jsp, this is the component that I've now previously uploaded to the compromised web server. You'll see if I hit it with a browser, it doesn't do anything. It just verifies that it's there and that it's running. And what I'm going to do over here now is I'm going to fire up the Reader client. Now, the Reader client is also a little Java application, and you'll see that I give it the name of the server that I'm connecting to and the port, and then where the executable component is running. So I basically point it to my Java server instance that's running on the compromised machine. What you're seeing here, of course, is running on my own machine. All right? Guess I don't need that. Okay, so that fires up the Reader client, which is now running on my machine. And you'll see the Reader client creates this listen port on port 1010, and that basically gives me a little administrative interface. And if I can find that window. There it is. No, that's not it either. So I'll do a new one. Okay, so what I'm going to do now is I'm going to connect to my local Reader admin interface. I'll draw you a picture for all of this in a minute. It's not making any sense. All right, so this, what you're seeing over here at the bottom, is a small little CLI for the Reader client. So I'm going to tell the Reader client what I want it to do. And what I want it to do, don't get intimidated, that's all still coming. What I want it to do is this. All right, I'm going to tell it to create a tunnel and listen on port 1234, and then tunnel that to that IP address on this port. All right, so now it's got a local listening port on my machine on port 1234. I'm now going to take a remote desktop client. I'm going to connect to local host on port 1234. Are you kidding me? Okay, I've got a problem with my remote desktop client, so I'm not going to do that. Not really sure why that is. All right, I'm going to do that again. Sorry, I'm not going to use RDC. I'm just going to use SSH. Same story. I'm going to create a tunnel. Let's make it listening on 9999. All right, so sorry, I've done it again. I've created a listener on my machine, this time on port 1111. That's going to tunnel through to the compromised web server where the JSP server component is running, and that in turn is going to tunnel through to the target IP address that's specified here on port 22. So what that should mean is if I now telnet to localhost on port 1111. You'll see the data being tunneled in the background here. And boom, there I get my connection. Right? So it's interactive TCP connection being tunneled via HTTP. Let me just show you that in a diagram, just so that everybody's on exactly the same page. So this is the scenario here, right? We're tunneling through a firewall. We've compromised this machine over here. This is the Linux box over here. And we're aiming for this Windows machine or this machine somewhere else in the private network. So I've got two components. I've got one component, the reader client, which I fire up on my notebook. And then the second component, the reader server, which is that JSP component that's built on the compromised web server. Right? And again, like I said, we've got ASP and PHP that does that also. And then what happens is I connect locally to the listener that I create on my machine. And that listener is now basically going to take the inbound TCP connection. It's going to chop it up into blocks, hex encode those blocks, and then post them as HTTP requests to the JSP listener. The JSP listener takes those blocks out of the HTTP post requests, builds them back into a TCP stream, and sends that TCP stream out. And so what we've got is essentially a TCP over HTTP tunnel, which of course can be done over HTTPS, can be done via proxies, can be done with proxies and authentication, whatever the case is. And I'm sorry about the remote desktop not working. It's a funny on my remote desktop client. Right, so that traffic there is now HTTP, and so we've achieved our objective of having an interactive tunnel using only the available channel, which is HTTP. All right, so what this means, we have TCP over HTTP or HTTPS. It requires only the creation of a simple single JSP on the target. And of course, that isn't JSP specific. We've got it built in ASP also, and we've got it built in PHP also, which is relatively tricky to do if you want to do it in just one file. And we think that covers most of the common cases. So if you've got a web server that you can execute commands on, you can now tunnel TCP via that web server. Right. Okay, so where does that bring us in our sequence? We've had a look at reader.jsp. Like I said, that's now TCP over HTTP. What I want to spend a minute doing now is revisiting Squeezer. Now, Squeezer is a tool that we introduced at Black Hat last year. It's effectively a SQL injection exploitation framework, which is nothing new or sexy. But Squeezer does do one very important thing, or two very important things, which is what I want to draw your attention to here. The first is that it separates the delivery and the extraction. What I mean by that is when you, the way that you get the SQL injection in and the way that you get the resulting data out are separated. You've got different modules for doing both of those things, and those modules are interchangeable. And so what that does is it allows us to select how we want to get the data out. And at this point in Squeezer, there's 3 modules that have been implemented. The first is the traditional HTTP errors. So we extract our data using HTTP errors. The second is we use a reverse DNS tunnel, which will be similar to the techniques that I described earlier. And the third, the new thing that we introduced, is we can extract data using time. Simply by looking at how long a request takes to complete, we can infer what the value of the data is that we're looking at. I'll show you that in a minute. And then I'll give you a quick demo of Squeezer so you can see how it runs. So, Squeezer introduced 2007, another injection tool aimed at Microsoft SQL, but it treated injections slightly differently in that it split the content generation and the return channels from each other, so you can mix and match them in these different ways. And I'll show you how that works. The first thing that we're going to do is we're going to generate content using some kind of SQL injection. Right? So that could be SQL injection XP command shell to execute a command. It could be access to a table, or it could be access to a file. Right? We then store that data in a table inside of the database. So we don't try and extract the results of the SQL injection. We leave it in the database where we know we can get it. And then we pull it out using whichever channel we want, which is a separate process which we can run separately at some different time. And this works very well. It works good enough for most batch applications, so things like command execution and file copying, it works well. And theoretically, you could use it for real-time data channeling also, right? You're executing a command, you're putting some data down, you're pulling that data out. It's kind of like a queue that you could use for network traffic also. It seems a little slow, but technically it might be possible to, in fact, use this technique to channel TCP connections also. And we'll get back to that a little bit later. All right, so the first example I wanted to show you is using Squeezer via DNS. It's really simple. I'll just jump straight to the picture. It works like this. Via the firewall, you deliver your SQL injection attack. And in this case, we're executing ipconfig/all. That generates some output, right? The output of the command is generated. But we don't try and access this output. What we do is we have the output written back into the database. So the output of the command, it's sequenced and indexed, and it's put in a table that we create on the database. We then use a second SQL injection string, and effectively what we do is line for line, we encode that output. And for DNS, we encode it as hex. I can't remember exactly the length. I think it's 256-byte hex strings that gets encoded as, and then written in the form of a fully qualified domain name like you see there. And then we use a third SQL injection string to initiate a DNS lookup for that name. And so that string is then sent via DNS out onto the internet, where we can pick it up on our fake DNS server. We can then extract that encoded string, decode the hex, and we get the results being reconstructed on our side. So it's cute, and it's a sort of sexy, robust implementation, but in this case, it's nothing new. What's more interesting is using time as a reverse channel. And this was the thing that made made Squeezer a little bit new, I think, was we said the following. We said if you've got inbound traffic, you make the connection to the web server injects the SQL. Now that SQL request takes a certain amount of time, and the connection to the web server is only torn down when the SQL request has completed. And we can measure that time, right? We can measure how long it takes any given SQL request to complete. So we take the first 3 steps from the DNS tunneling technique. We execute whatever we want to execute via SQL. We put that data back into the database in a table that we create, and we encode it. But this time we don't encode it as hex, we encode it as binary. So now the output data is stored in a table on the compromised SQL server, effectively as a series of 1s and 0s. Then for every bit in that string, what we do is we read, using T-SQL, we read the value of that bit, and depending on whether the value is a 0 or a 1, we wait some predetermined amount of time. So effectively, hypothetically speaking, we would say if the value is a 1, wait 10 seconds before completing the request, and if the value is a 0, wait no seconds before completing the request. And in that way, we can infer what the value of each individual bit is. We can reconstruct that bit string on the attacker side, and in that way effectively extract data. And it works very well. We can extract the output of commands, we can extract content from the database, and we can even extract things like binary files, all using time. And what's very nice about that is, of course, that there's no visible outbound traffic. All you'll see is the inbound HTTP requests, the inbound SQL requests from the application to the database, but the data that we're extracting never actually is visible on the network. We infer it on the other side. Once you start thinking like this, there's a whole myriad of other things that you can do, but I think this example serves for our purposes. All right, let's have a look. If anybody wants this lovely lady's number, I can get it for you. She's also an Aries. All right, let's kill that down. Let's kill that down. All right, so this is basically how the Squeezer interface would work. You fire it up like that. It's got a config file that I've pre-configured. You see I configure the location of the request, the insertion string, there's the ASP that I'm attacking, there's some other small configure options that I can set. And then via the interface, I can choose my channel. So I could say my channel is DNS. Oops, that's not DNS. I can say my channel is DNS, or I could say my channel is time, or I could say my channel is HTTP. All right, and I can then choose what I want to do. I can say I want to copy, I want to do SQL, I want to execute a command, whatever the case is. I say I want to execute a command, and then I can execute whatever that command is. And with a little bit of luck, there it executes. All right, so again, using Squeezer is nothing different. If you guys have used SQL Ninja or Injector.pl, or I know there's a whole array of these kinds of tools which all work in a similar way. What's interesting to note here is the separation of the delivery channel and the outbound channel, and particularly the use of DNS and the use of time as a data extraction channel, and a way of getting data out from a SQL server. All right, I have to move on from the pretty lady. So that was just a quick revisit to Squeezer, and you'll see in a little while why that's important to us. So Squeezer is effectively a SQL injection delivery engine, right, scripted in Ruby. So the next thing we want to look at is something that's also not entirely new, but is something that possibly hasn't been explored enough, and it's the concept of OLE object instantiation under SQL. So we all understand what an OLE object is. It's this executable package that's very common under Windows. And what we can do is under SQL, we can, using T-SQL, we can create and execute OLE objects. Right? So effectively pieces of Windows binary that can be created in and stored in and executed on a SQL server. And it's something that's not very well understood, or at least it's not very extensively used. Chris Anley spoke about it in 2002, and he showed how using an OLE object inside of SQL, you can read and write to the file system, you can execute a shell, and do a whole lot of other things, but we don't really see it. And possibly it's because the impact of this was lost at the time. So we spent a little bit of time looking at it, and we built effectively a port scanner inside of SQL using this OLE object server XML HTTP. Now, server XML HTTP is an OLE object that allows you to make XML over HTTP requests to web servers, and you can specify the IP address of the server that you want to connect to, and you can specify the port that you want to connect to, and you can read some error codes back from your outbound connection. So if your connection fails because of a TCP timeout, that's a specific error code. If the connection succeeds but you don't get proper HTTP back, that's a different error code, et cetera, et cetera. And so we can learn a little bit about the IP address and port that we're trying to connect to with this object by reading the return values. All right, skip over that. So this is how it looks. You'll see that this, what you're looking at here, is pure T-SQL. So you could execute it from a SQL query editor, or you could execute it using SQL injection. And effectively what we're going to do is we create a URI, so that's the IP address and the port that we want to connect to. We instantiate that OLE control, and we configure some timeouts. We then initialize the control and make the connection. We read back the status of the report, of the return status, and then we can effectively parse that error code to derive what the status actually was. And you'll see there we can differentiate between blocked ports, open ports, filtered ports, and we can even determine whether an open port is actually running a web server or not. So it's a relatively functional port scanner coded in T-SQL that runs out of the database. Now, I'm not going to show you that using SQL injection because it's a bit cumbersome, but I will show you it on an actual database. So you'll see there's the there's the stored procedure that we created. And again, given that I've got sufficient privileges using SQL injection, I can create this stored procedure on the database using something like SQL injection, right? I don't have to have this interface. And then using the world famous exec verb, I can invoke that stored procedure, which is stored in the master database. It's a little bit big. And let's say I request a connection to port 134 on port 21. If I execute that, it comes back and it says that it's blocked. And let's say I change that to 22. Execute that, it says 22 is open. Let's say I change that to 8080, and I execute that. Then you'll see it's open, and it recognizes that it's a web server because what it got back was valid HTTP response. All right, so I'm not too excited about having a port scanner inside of SQL. I think it's quite cute, but I'm not that excited about it. What I'm excited about is what that means for us. I did that already. This guy is working out for a part in Star Wars Clone Wars. Is it Return of the Clone? How did that movie go? He wants to be one of those robot guys. All right, what does it give us? It gives us a SQL-based port scanner, which is cute. It's implemented in a stored procedure, no footprint on the file system, no having to upload third-party binaries. I'm scanning, obviously, from the location of the SQL server, so I've got whatever view of the network that SQL server has. There's very, very limited inter-protocol connections, protections at least. There's 5 or 6 ports that the object won't allow you to connect to. But it certainly shows us the power of these objects and suggests that they need some more looking at, given that this whole object can be created and executed and the data extracted, all using those SQL delivery and data extraction techniques that I showed you with Squeezer. So of course, the next natural step for us would be to build something like this into Squeezer. Now I can do a port scan from your SQL server using time to extract the results. All of this leaving no footprint either on the server or on the network. All right. So, so this idea of separating the delivery channel and the extraction channel with Squeezer was a good one, because this can now be executed using a simple SQL query. All right. So bringing it all together, I want to now spend a little bit of time looking at specifically SQL Server 2005. I'm going to tell you in a minute why. We're going to look at a very specific procedure called SQL HIRBSecConf. We're going to look at 2 important new services that were introduced with the new version of SQL. And those are this native XML web services and then also CLR integration. That's the CLR is a common language runtime. And then I'm going to give you a demo of how we can pull all of this together. And hopefully this will all start to make sense for you now. So when SQL 2005 came out, pen testers started to quiver. And by all accounts, it was going to be tight. The news that we were getting back is that it was built rough, it was built tough. Microsoft had this SD3, secure by design, secure by default, secure by deployment model. And so SQL 2005 looked to be a pretty hard nut to crack. But they made 2 fundamental mistakes. The first being they added a whole lot of new features, a whole lot of new functionality. And of course, as we all know, with functionality comes complexity, and with complexity is the enemy of security. So some of this new functionality looks to be really, really interesting. I'm being attacked by in Afrikaans we call this a muggie. Those tiny little flies. Anybody know that? First is these new features, and the second problem is the continued use of in-band signaling. Basically what we mean by in-band signaling is that the same channel that you use to extract data from SQL is used to configure SQL. All right? So when somebody exposes a SQL server to you in some way, either directly or via a web application, then they're also exposing effectively an administrative interface for that service to you. And that leaves them with a lot of problems, as you'll see. Right. And at the heart of that is a stored procedure called HIRBSecConf. And HIRBSecConf effectively allows you to change configuration settings of a SQL server. So for example, in the old days, Microsoft used to say, hey, if you want to have a secure SQL server, you have to turn XP command shell off, with HIRBSecConf, we can turn it back on again. In fact, just about everything that we're told to turn off to make a SQL Server secure, we can turn on again with HIRBSecconf, provided, of course, that we have the correct channels, at least correct privileges. And so this sharing of the data interface and the configuration interface creates a huge security vulnerability. So you can see some examples here. Ad hoc distributed queries is a functionality that should generally be turned off. In fact, I think it's turned off by default. It's used in brute forcing tools and things like SQL data thief. Should be turned off by default, can be turned on again using HIRBSecconf. CMD shell should be turned off, can be turned on again using HIRBSecconf. And CLR integration, which I'll get to in a minute, which is an extremely powerful feature that effectively allows us to upload and execute .NET runtime binaries, should also be turned off by default and can be turned on again using HIRBSecconf. And so this idea of in-band signaling gives us a lot of power over a compromised SQL Server. So we've spoken a bit about in-band signaling, which is the one problem with SQL 2005. The other problem with SQL 2005 is these new features. And we're going to focus on two. One is native XML web services, and the other is CLR integration. So we'll start with native XML. Basically how it works like this is Microsoft thought it wise to make it possible to create a web service and bind it directly to a SQL procedure. Right, so now you don't need any more application layer between your web service and the SQL server. The web service's functionality can be written in and stored in SQL directly by exposing what they call an endpoint. So that any device that can parse XML and submit HTTP requests can now access a SQL server. So you look at that little diagram at the bottom, you'll see the client is connecting to the endpoint. The endpoint is basically a little XML over HTTP web service, and that endpoint can then execute raw SQL and return the results. And this is all done very, very point and click. And one of the vulnerabilities that this potentially introduces is the idea of denial of service. Because what I can now do is, if I can execute SQL, I can use T-SQL to create a web service endpoint and bind it to any location on the web server. So what you're seeing there is the web server directory on the left-hand side here. You're seeing a web server directory called test. Right? This is something that potentially is running, I can't drive my mouse so good. This is something that potentially is running on the web server. Over here you see a little snippet of SQL where I create an endpoint and bind it to test. And SQL, which is running a system, then effectively takes over that location on the web server and creates a little web service that's running there. And what you see at the bottom is the WSDL, for those of you familiar. The web services descriptor language output for that web service. So effectively, I've created a website and overwritten any location on your web server. And the way it works is I can do that for any virtual host. So if you think to something like a virtually hosted environment where many companies have got websites running on the same server, those websites are protected from each other using file system access permissions. I can now basically overwrite any one of those websites using SQL injection, right, via any one of those websites. Does that sort of make sense? I'll show you an example now, and it'll all come together for you. So what I'm going to do is I'm going to show you how I can create an XML endpoint using SQL, and I'm going to do it using SQL injection. You see I give my endpoint a name. In this case, it's EP2. I set location, in this case, /sp. I leave the ports clear. And that's about all I need to create an endpoint. Now, what we initially set out to do is we said, well, perfect. If I can create a web service using SQL injection, then the logical thing to do is create a web service that takes arbitrary SQL and executes it and gives me the output, right? So a little SQL query engine. That would be the simplest and the easiest thing to do. But guess what? We don't even have to do that, because you see that batches equals enabled? Batches equals enabled automatically creates a web service which will take arbitrary SQL and execute it and give you the output. So I don't even have to code that. I don't have to write the procedure that'll do that. simply creating an endpoint with the attribute batches equals enabled will do that for me. So what I'm going to do is I'm going to take that SQL. You'll see it's this ugly piece of SQL over here. Anybody see my mouse? There it is. All right, so that's a standard SQL injection. I'm executing this piece of SQL over here. I've got a little vulnerable application over there. Let's just have a look. Test and test single quote. All right, you've all seen this before. Effectively, what I'm going to do is I'm going to paste that in there. All right, so that's my SQL injection string, which is going to, let me just, before I do that, let me just show you this. This is the server that I'm compromising, SP directory. You'll see there's no SP directory there at the moment, right? Nothing. So we go back. We say test single quote. Good old OLDB provider. Drop that injection string there, and it executes. All right, so I've basically now injected the SQL to create a SQL endpoint. Quickly check something. And if I now go back here and I hit the SP directory, you'll see I'm now asked to log in. And I can even request the WSDL. Voila. All right, so I've created, using a single SQL query, which I injected via SQL injection, I've now created a fully functional web service. And this web service, simply by having that attribute configured, will allow me to send arbitrary SQL commands. So we created a little XML client over here. It's this little thing called SQL.pl, just a cheap way to do it. There I specify the IP address of the server that I want to connect to, and there I specify the query that I want to run. And if I've done it all right, bam, there's the output, all right? And of course, because it's arbitrary SQL, I can change that into something like that. And I've got now command execution over HTTP via the SQL endpoint that I created using SQL injection. So again, sticking with my objectives that we only use the existing channels, in this case HTTP and SQL. All right, so we're starting to get a sense of the real power of this SQL Server 2005 and why this additional functionality becomes dangerous. I want to move on to the next feature quickly. Time is running a little bit out, which is this common language runtime integration. And without spending too much time on it, effectively what this means is that in SQL Server 2005, I can take any .NET bytecode, so any .NET application, and upload it directly to the SQL Server and execute it out of SQL. Now, why this is good is because previously, if I wanted to do complex things like a port scanner, I would have to code that port scanner using T-SQL. When we built Squeezer, we had a really hard time. Doing that because T-SQL is not a particularly pretty language. Sorry, I've lost myself. Self. But now we can basically write it in C# or whatever or Visual C++, whatever the .NET language of your choice is. Take that binary, upload it to SQL, and execute that binary. Now that feature should be disabled by default, right? CLR integration should be disabled by default. But luckily, via this in-band signaling, via HIRBSecConf, I can turn it on again. So if I've got SQL injection, I can turn CLR integration on, and then I can upload any .NET binary to the SQL Server and run that again using SQL injection. There's some funnies around privileges, but effectively, if I've got SA, so if my application is connecting to the database using SA, then I can make it work. Maybe just a few more steps required. So the question is, how do I take this .NET assembly, how do I take this .NET executable and get it onto the server? And effectively, I've got three choices. The first is I can compile it in place. So effectively, what you're seeing at the bottom there, where it says number 1, is a series of echo commands to construct the C# line for line. Once I've got the raw C# code on the file system, I can invoke CSC, which is at a predefined location, and compile it. And then effectively, I call this SQL command at the bottom here, create assembly. I point it to the program that I just created, and that assembly then gets loaded into SQL and can be executed via SQL. So it's cumbersome. It'll take me a long time to do it, but it's a technique, this technique of building code on a victim server, something we've been doing for a long time. Remember the upload scripts that we used to do? So we can basically use the same technique, and it will work. But it's a bit of a bore. The second technique I can use is I can create an assembly from a UNC path. So I can say, listen, fetch this binary from this place using effectively a map drive and load that. And you'll see from that little picture, basically what's happening is the database is making an outbound connection. It's fetching the DLL down and loading that into the database from where I can execute it. This is a much more elegant technique, but of course it requires outbound TCP connections, which I may or may not have, so it sort of defeats the purpose. And here comes the real sex. What I can do is using SQL, I can insert the hex-encoded binary directly into the SQL server. All right? So if I take a functioning .NET assembly, I hex-encode that, I can create that assembly on the database, basically using SQL. And what that means is I can do the whole thing purely using my existing HTTP channel if I've got something like SQL injection. So I'm going to show you quickly how that works. All right, that's me. I promised you a picture of me in my bodybuilding outfit. All right, so let's have a look over here. Right, so I've got a little executable here called socket.exe. It's that guy there. And if I encode it, you get something that looks like that. Right? That's the hex, effectively, for that little binary over there. And this, what you're seeing here, is the SQL server that we're going to compromise. I just want to show you, these are the listening ports at the moment. Right, so what I'm going to do is I'm going to use that same SQL insertion point that we had earlier. And I'm going to create an assembly directly from the hex. Okay, now that's this SQL that you see here, which I'm not going to try and type out. I'm just going to copy it straight from there. All right, so same server, same SQL injection point. Remember, we're there. Put that whole thing in there, and it executes. And effectively, using that single SQL command, I've now created that whole .NET assembly in the database, and I can now create a stored procedure from it, which is that SQL over there. Again, it looks complex, but it's surprisingly easy, and I can now execute that stored procedure, just like you would execute any other stored procedure, except remember that this is brand new functionality in the form of a .NET binary that I've just uploaded. Pop that in there. You'll see it's taking a little bit long, and the reason for that is because if I have a look here now, you'll see I've created the new listener on the victim machine. So basically, I've created a little executable that creates a listener on the Windows machine. All right, and I think that brings it to an end. The power of this thing, I think, is obvious, because effectively it means I can now upload and execute arbitrary Windows binaries inside of SQL. And where we would like to go with this, and we actually got this to work, but it's a little bit of a hassle, so I'm not going to try and show you this. But effectively, we wrote a tool called Server, which is a .NET SQL to TCP tunneling tool. I'm going to try and explain to you how it works. Again, this is the scenario. We have the SQL server behind the firewall. We hit it via the web server. We've got another machine somewhere in the private network that we're trying to get to. What we do is we use this technique to upload the little binary into the SQL server. And then, so that then sits over there, and it runs on the SQL server. And then we use SQL injection. So look carefully. We use reader to create a TCP listener. That then basically takes the TCP stream, breaks it up into a whole lot of hex-encoded blocks. Remember exactly the way that SQL did it, and passes it on, at least that Squeezer did it, and passes it on to Squeezer. Squeezer then basically takes each one of those hex-encoded blocks and inserts it into a table on the database. Right? So I've now got a table on the database consisting of my TCP stream that's been encoded into blocks. And server then reads it out of the database and makes the outbound TCP connection. So effectively what I have there is I've got TCP coming from the client to reader. I've got that TCP being chunked up into little hex-encoded blocks. I've got those blocks being, sorry about my mouse, I've got those blocks being inserted into a table on the database server using SQL injection, and then I've got them being read out by this third-party binary, effectively, reconstructed into a TCP stream, which is then sent out over the network. So effectively what I've then got is I've got TCP tunneling over SQL injection, which again lives up to all of our objectives, which is that we use only the existing channels. All right, my time is up. Thank you very much, everyone. I'm sorry, I don't think I've got any time for questions.
We can allow one question, definitely. It looks like a very interesting presentation. Anybody with one question before lunch? And then maybe you can continue further questions during lunch?
Sure.
Yeah? Any questions from the floor? Okay, yep.
Microsoft has released a new version of SQL Server 2008. Have you tested it? Can you use the similar method to do the SQL injection?
I haven't. I honestly can't tell you. The question is whether 2008 fixes these issues. We haven't looked yet. Sorry.
During lunch then, I'm sure Mr. Charl will be around for the rest of the day. And now you know how he looks like, so he can't run away. Thank you very much, Mr. Charl van der Walt. We will now break for lunch, and I'll see you back here at 1:30.